Alright, so just to clarify where we're up to with our series of acid-base titrations. So if you remember going back to the previous stuff that we recorded, we made up a standard solution of sodium carbonate. That was where we actually started. And we had to do that because we knew the sodium carbonate was pure. That was fine. We did that, made up our standard, and we used that standard to standardise the HCl that we were given. We were given an approximate concentration of HCl by the lab assistant, but we weren't quite sure. We had to make sure, we had to prove to ourselves, using our known, and we come up with a concentration of HCl. We then used HCl to work out the sodium hydroxide, because the sodium hydroxide has got an issue. What was the issue with sodium hydroxide?
It wasn't pure, it was in a liquid solution.
It wasn't liquid. Sodium hydroxide is a solid, but what does it do?
It gets water from the...
It does, yeah. So in other words, it absorbs moisture over time. So this is a chemical that we're not sure about how pure it is, because from day one it absorbs moisture. So if I weigh out 5 grams of sodium hydroxide, and if I were to put it into a volumetric flask, well, 4.8 grams of that might be sodium hydroxide, 0.2 could be water. We don't know. So we make the solution, okay, or we get a solution that's made for us, and we have to standardise the sodium hydroxide. It's the first step of every experiment that we're going to do, all right, wherever we're using sodium hydroxide. Now, the last set in this sequence is working out the acid content in something. Now, in order to do that, we have to work out the acid content, or the example we're doing is acid content in vinegar, all right? But we are using a mass of vinegar to work out the acid concentration. We have to know, by the way, what the acid is in the sample that we're testing. So we're looking at acetic acid because I have to be able to write an equation for the reaction. If I can't write an equation for the reaction, then I don't know what the stoichiometry is. I don't know whether it's a 1-to-1 ratio or a 2-to-1. So that's the important thing as well when you start to talk about your design experiment on Wednesday, or whenever. Do I see you Wednesday?
Yeah.
Yeah, Wednesday, is where you get together with your group and you work out, you start actually noting this out yourself. So what am I going to do the acid content in? And once you work out what it is, you need to do some research to find out what the acid is. Okay? Then you've got to work out how to extract the acid, etc., that we'll go through later. Alright, now this question here, or this titration, asks you to give the answer in percentage weight by weight. And I'll say that again, percentage weight by weight. What I want to do is I want to move over to here, which are some concentration terms that we haven't yet talked about. But you need to know, alright, otherwise it's a bit dodgy to do this experiment. We've already done moles per litre. We know that concentration unit, we know it well, we've done calculations on it, alright. That was our equation, we called that molarity. So this little one up here, that one we've used before, and we should be familiar with moles per litre. All of our calculations in all of these are based on that concentration unit. And it will be, alright, for the purposes of everything, but we could transfer any concentration that's in moles per litre into other units. And I wanted to just highlight these other units before we do the calculation over there. So moles per litre, right, can be transferred into another concentration unit called grams per litre. It's not rocket science, hopefully you can work this one out. I want to go from moles to grams. Here's our equation, N equals mass on molecular weight. So to work out mass, we multiply it by the molecular weight. Here's N, there's big M, alright, molecular weight, we multiply it, and we get grams per litre. Is everybody okay with that one? It's a simple conversion with whatever we're using. That's what you need to know. You've got to know what the acid is, because you need to know the molecular weight of the acid to do that conversion, or anything for that matter. Now, there's a unit that we also have to use in this that I'll get to eventually, called percentage weight by weight. But typically, when we actually get to year 12, or if you get to year 12, we use another concentration term called grams per 100 mil. This unit is called percentage weight by volume. Slight change. Weight by volume. Here's the volume. It's in 100 mils. and the weight is grams. So that's normally grams per 100 mil. Now to go from grams per litre to grams per 100 mil, any ideas how we would do that? Just giving you a bit of a hint up here. It is, what do we do? Times it by 10 or divide it by 10? Divide by 10. Because I've got a litre, okay, of Coke, whatever, and I want to work out the acid content. If I take out 100 mils, I've got 1/10 of the mass, provided it's a homogeneous Coke mixture. All right? Because we don't want to shake it too much, so do we? All right. So we've actually gone from here to here. We actually divide by 10. 1,000 mils divided by 100 mils is 10. We've got a fraction of the total volume. So we're going to have a fraction total mass. Does that make sense? So if I halve the volume of something, I've got half the moles. Okay? Or half the mass. Same thing. Going the other direction, I would multiply it by 10. Now here's the issue with this experiment. It's another unit that doesn't appear, all right, officially in any of the stuff that you'll get in terms of the course outline, but it's percentage weight by weight, grams per 100 grams. So the practical that we're doing, okay, at stage 1 says, how many grams of acetic acid is there for every 100 grams of vinegar? That's what it's actually asking you to work out. So if I were to consume 100 grams vinegar, how much acetic acid is in that 100 grams? As a percentage. And it happens to be nice because percent is of 100. Alright, so we're asked not percentage weight by volume, we're asked percentage weight by weight in our calculation. Now you could have done percentage weight by volume, could have done that, not a problem. Alright? That would simply mean taking a volume of vinegar and not a mass. You could have actually done a 20 ml sample of vinegar. You could have worked out the mass in 20 mils and then work out the percentage weight by volume. You could have done it that way. But, all right, the text that we're using, the resource that we're using, said we're going to weigh out the vinegar, not use volume. So this is the different experiment. This is different to every titration that we've done, because in every titration we've done, we've worked out a volume. We've worked by volume, not by mass. Okay, some of you are still looking at me blankly. All right, let's go through the calculation, and hopefully that will clarify things. And I've got Leandro's group and Senna's group results, and we'll work on your results. Okay, so you can help me as we go through. All right, now, so every time we do a titration, we have to have a known or a standard. We've worked our way right through. This is our standard. Here it is. All right, so the first thing we have to do is we've got to work out the moles of the known. That's nothing unusual. So we're going to work out the moles of the sodium hydroxide. So N equals C times by V. It's not rocket science yet, I hope. The concentration is 0.121 times by 24.75 over 1,000. All right, and that will give me the moles of sodium hydroxide in the reaction. We've done that already, probably 1, 2, 3, about 6 times, all right, during our titrations. Number 2 is always the mole ratio, because it hasn't changed, Ben. This is the same thing we do, we repeat it. Balanced equation, moles of known, moles of unknown, sorry, mole ratio, moles of unknown. So the Moley Bible is locked in, all right? Now, so we've got to have the mole ratio, and we want the mole ratio of the sodium hydroxide. That's our known, so I'd like to put the known left to the unknown, and that is simply 1:1. Hasn't changed at all. All right? Nice, simple 1:1 ratio. So that tells me that the moles of the acetic acid are, or is, what are the moles of acetic acid? Leandro, what did you work out to be? Moles of acetic acid. What'd you get?
So 0.0023.
Okay, and that's just evaluating that, correct?
Yep.
Good. So that's the moles of the acetic acid 1:1, same with the moles of sodium hydroxide. All right, now, so that gives me the moles of the acetic acid. All right, where do we go? Sorry, what did I do that for? to find the concentration of acetic acid. We've got to work out the percentage weight by weight, don't we? So I've worked out the moles, okay, of acetic acid.
So,
What do I do next?
that value is actually should be 0.0024. So I only use 0.121, not the accurate value.
What'd you use?
So I have to use like comparative.
What's your answer?
So it's 0.0024.
Yep. That's the moles that you calculated of sodium hydroxide?
Yes, I only put in 0.121, so I was going to get a different value to the
That's okay.
Let's expect.
Alright. So we worked out the moles of acetic acid, because that's all we can do. Okay? And then we worked out the moles, okay, we worked out moles of sodium hydroxide, then worked out the moles of acetic acid, alright, using the ratio. Now, normally, yes, you would do this. Normally you would then work out the concentration of the acetic acid. But we don't have a volume. Alright? We don't have a volume. If I had a volume of acetic acid, if I was working out the concentration of acetic acid in the vinegar, I could do that. Because I would have pipetted 25 mils or 20 mils, okay, and it would have titrated that. But we have actually got a mass. So what do we do next? Yeah, it's the only thing we can do, alright? So I want to work out, so this is reacted as a 1-to-1 ratio. The indicator box, that's phenolphthalein by the way, has given me an endpoint, and it told me that 24.75 mils sodium hydroxide completely neutralised whatever acetic acid was in 4.01 grams. So although I've worked out the number of moles, I've actually got to work out the mass. Because this is what I'm trying to work out. This was the total that I started off with. Not all of it was acetic acid. Only a portion of it was. That's what we're trying to work out, percentage weight by weight. So we're going to transfer this into a mass. I'm going to call it the actual. So the actual mass of CH3COOH. Now, if this is the number of moles, okay, as Gordon told us, okay, mass equals N times by again. So hopefully you worked out the mass. So what did you get for the mass of the acetic acid? Mass of acetic acid.
Again, I think I may have put it wrong.
Okay. Checking my power.
Yeah. The 0.025. That's why I multiplied 0. No, that's right.
Okay. N is, hopefully we got it before this thing dies, 0.024 times by the molecular weight for acetic acid.
Yeah, I got, yeah. Yeah, I'm just going to go through it right now. Yeah, I already found it. Yeah. So 0.145 grams.
What'd you get?
Yeah, 0.145 grams.
That's what you got. So that's your answer. So you got 0.145 grams. Now, can you see how I calculated the 1.45 grams? But you've obviously used the molecular weight for acetic acid?
That's 89.02.
Good, thanks Tina. So it's 89.02. We'll believe that you're true, or that you're okay at this particular point. That's actually accurate. It's alright, no, we'll work with that. Hopefully it is, otherwise it's going to look stupid on our...
Use the molecular.
Oh, that's okay, molecular is always correct. Alright, now, so here it is. This is really important. So, we don't have 4.01 grams of acetic acid. Of course we don't. Because we know that the vinegar is diluted. But what we actually worked out was that we've got 0.145 grams in the sample that we titrated. That's what we worked out. Hang on a second. So we've actually got this. We've got 0.145 grams of acetic acid in 4.01 grams. So now we can work out the percentage weight by weight. Hopefully it's reasonably straightforward. So the percentage weight by weight calculation now is we take this mass that we've calculated that reacted in our sample, 0.145. We divide it by the total mass of vinegar in this sample, 4.01. We times it by 100, and what is your answer?
Divided by 4.01. Yeah, that's what I did. 0.036.
What'd you get?
So 0.036, and just multiply that by 100.
Yeah. So which is
3.6.
good. So that is 3.6% weight by weight, which is around the right mark. Okay. It's about 4. I think last year worked it out as 4.2%.
I got that, but see, I gave it the wrong value. But see, this is fine because now everybody knows that value.
Yeah, that's all right. We'll work with that. All right. Now, so the point is, I've done one calculation using the mass, okay, which is not what we've done, and this is where I think people are getting a little bit confused, because we normally have a volume over here. You could, in your practical, work out the concentration of acid in. You don't have to do the percentage weight by weight. You don't have to do the weight by volume, but you could. Okay? Sometimes it's easier to do that. But again, you've got to work that out because it's your experiments, not mine. So basically what we've done is we've worked out weight by weight, we've used a mass. Now, a lot of people have got different masses, and then they take their tidal values and they want to average their tidal values. If you've got a different mass, which most people have, although I know a few groups somehow have managed to have the identical mass, if you've got a different mass, then you can't use concordant titers. Why not? Different masses, different number of moles, okay? When we did it, for a volumetric analysis, we had 25 mils, 25 mils, 25 mils, 25 mils delivered from a volumetric pipette accurately. We can then use concordant titers in that scenario. In the acid weight by weight, because we're using a mass, unless all your masses are identical, you can't use concordant titers. But I don't want you to sit there at the balance or stand at the balance for half an hour to try and get the exact mass every time you do your titration. Alright, so we're going to use the weight by weight.
No, which, if we have like different masses, which one do we use?
It's a good question. So if you do 3 titrations, I think the book asks you to do 2. It's probably not any advantage doing any more than 2, unless you really miss the end point, okay, which is that pale pink. But Para said, which one do we use? So which one do we use? Do we use this mass or do we use the other mass to do the calculations? It's a good question. I thought I went through it last week, but maybe I didn't. We've got different masses. We've done 2 titrations. So which calculation do I do? The answer is you do both. So if you've got different masses, okay, we'll talk about error a little bit later as well. If you've got different masses, you've got to calculate it for whatever mass you got for the first titration. You get an answer. Then you do another calculation for a mass for the second titration, and you average the 2 answers. That's what you have to do. Those people that have the same mass are a little bit more fortunate because they've actually got a tidal value that they can use for a concordant. They only have to do 1 calculation. Alright? But that'll be rare. You won't necessarily be able to get the same mass each time. Questions? Alright, any questions in relation to this? Because that's where you are heading when I start talking today. Alright, let's get into it.